Good morning, everybody. Today we are discussing the problems of the nuclear chemistry. So, the first problem, how many alpha particle and beta particle are emitted in the conversion of the neptunium 237 to bismuth 209? So, for this, first of all, we have to note the question first. So that is we have to find out the number of the alpha and beta particle emitted during the conversion. They are given the conversion, that is neptunium 237 to bismuth 209. So first of all, we have to find out the difference in mass number between the reactant and the product. So mass number is very high for the reactant than that of the product. So 237 minus 209, so we will get 28. Then we know that alpha particle actually it is a helium nucleus. So the difference in mass must be in 4. So we have to divide the difference in mass divided by 4. So we will get the total number of the alpha particle that is emitted. So 28 divided by 4, so we will get 7. So if the 7 alpha particle are emitted, the total difference in atomic number must be 7 into 2, that is 40. So the actual difference between the atomic number is 93 minus 83. So we will get 93 minus 83, that is only 10. That means number of the beta particle emitted is 14. That is the actual difference which is formed due to the alpha emission, minus 10. So we will get 4. So 4 beta particle and 7 alpha particle is emitted during the reaction. Now we are moving into the next problem, that is mass of a proton is equal to 1.00758 AMU and the mass of the neutron is equal to 1.00897 AMU and the mass of the helium nucleus is equal to 4.00820 AMU and calculate the binding energy of the helium nucleus in million electron volt and in joules. So in question, it is clear that the question is the calculation of the binding energy of the helium nucleus in terms of million electron volt and in joule. So first of all, we have to find out the mass defect. We know that the mass defect is the difference between the number of the particles in an atom minus the total mass of that atom. So we know that the helium nucleus consisting of the 2 protons and 2 neutrons. So 2 into the mass of the proton plus 2 into mass of the neutron minus the actual mass of the helium nucleus. So we will get the mass defect as 0.0249 since the every mass of the proton and neutron and nucleus of the mass in AMU, the mass defect also expressed in AMU. But our question is calculation of the binding energy in terms of million electron volt. So we have to convert this mass defect from AMU to million electron volt. So that the relation is 1 AMU is equal to 931.5 million electron volt. So we have to multiply this mass defect by this value 931.5 million electron volt AMU. So we'll get the binding energy is to 23.19 million electron volt. And we have also convert the binding energy in terms of joule. So this is the relation 1 million electron volt is equal to 1.6 into 10 to the power minus 13 joules. So that's why we have to multiply the above quantity with 1.6 into 10 to the power minus 13. So we'll get the binding energy as 3.710 into 10 to the power 12 joules. Now we are moving into the third question. Calculate the binding energy per nucleon in joules for the oxygen atom, which has a mass of 15.999410 AMU, given the mass of the proton and mass of the neutron and the mass of the electron and the velocity of the light. So, the question is same. They are asking the binding energy per nucleon. So first of all, we have to find out the mass defect, the delta M. For that, since it is given the mass of the electron, so we have to substitute the mass of electron, mass of the proton and mass of the neutron and total number of the protons and neutrons and electron. So for that, mass defect is the actual difference between the constituent of the nucleus, but since it is given the mass of the electron, that's why we have to note that quantity also. So here the mass defect is the difference between the constituent of the atom minus actual mass of that atom. So here the question is oxygen, so that's why the oxygen consisting of the 8 proton, 8 electron and 8 neutron, that's why 8 into mass of the proton plus 8 into mass of the electron plus 8 into mass of the neutron minus the actual mass of the oxygen atom. So we'll get 0.132514 AMU as the answer. Since the question is the binding energy, we have to multiply this mass defect into the velocity of the light. The velocity of the light is given 3 into 10 to the power 8 meter second inverse. So we have to substitute that value. Then we will get as 1.981 into 10 to the power minus 11. Remember one thing, the mass defect is in AMU. AMU is not an SI quantity, SI unit. So we have to, first of all, we have to convert this mass defect to kg. That's why we have to use this relation 1 AMU is equal to 1.661 into 10 to the power minus 27 kg. Then again they are asking the binding energy per nucleon. That's why we have to divide this quantity by the total number of the nucleon. Since the nucleus consisting of the 8 protons and 8 neutrons, the total number of the nucleon is 16. So we have to divide the binding energy by 16. So we'll get the value as 1.238 into 10 to the power minus 12 joule. This type of the question is very important and frequently asked university question. So I hope that you understood these three questions, and please do this question one time in your notebook. So then only you can thorough this type of the question. Okay, thank you.